Okay, so what I want to do in this short video is I want to talk about complex numbers, but I want to introduce this new version of our complex numbers, the exponential form. So we've looked already at Cartesian and polar. So Cartesian may be written perhaps something like this. Maybe x plus jy, and I've seen it in other texts written in slightly different form. A plus jb, or even a plus bj, lots of forms of the same thing. Essentially the x or the a is our real axis, so how far across left to right, and the y or the b would be of course our vertical movement to find out where our complex number is. Anyway, then we also looked at polar form, and I think in its nicest form, or most straightforward form, polar form might look like this, r theta. So we have our modulus and our argument. R is the length of the line to our point from the origin, and theta is just the angle from the positive real axis measured anti-clockwise to that point. We also have other ways of writing this particular form, polar form, and we might have r cos theta plus j sine theta. So that's really a recap, because what I want to do is just mention briefly exponential form. So we've seen these two different ways of writing Cartesian and polar, and we need to think about exponential. The good news is if you're reasonably familiar excuse me, with polar form, then we don't need anything else to rewrite it in exponential form. We just need to know r and theta. So typically exponential form in a general sense will look like this. Will be z equals re to the j theta. So if you know r and theta perhaps from polar form, then you're seconds away from writing it in exponential form, and vice versa. So let's look at a quick example. Let's have z equal to 1 plus j. So I'm picking a nice example, hopefully drop out quite quickly, but you can put different figures in there and see if you can get a sense of that. So if z equals 1 plus j, if I was to do a very quick sketch, there's my real axis and there's my imaginary, then I go 1 across the real and 1 on the imaginary, so there's my value there. I could convert that, because I've picked nice numbers, quite easily to polar form. So I want to know the length of that line r, and want to know that angle there theta. Well, the length of that line would be root 2, and my angle would be 45 degrees. So I know r and I know theta, so I should be able to write z equals 1 plus j, or z equals root 2 45 degrees straight into exponential form. However, while we can write polar form in either degrees or radians, we need to express exponential form in radians. So the first thing I want to do is just convert this. So that's the same, of course, as root 2, and then I want to convert 45 degrees to radians, which would be pi over 4. Now I have r and theta in the form I want them in. I can easily write them out again in exponential form. So r is root 2, so I get root 2e, and then I get j theta, and theta is pi over 4. So I've started off in Cartesian. I've picked a nice example I'll give you, but I've started off in Cartesian, I've converted to polar, made sure that it's in radian form, and now I have it in exponential form. So you should be able to see how you can work through any one of these three and find your way to the other types. Okay, hope that makes sense. Thanks for watching.